And really, under input-output analysis, this basically is a forecasting model. It's a matrix-based forecasting. It's a matrix-based forecasting what here? Forecasting model. It is a matrix-based forecasting model. Normally, what we shall, ladies and gentlemen, be given, you'll be given two things. You'll be given two things. So in this case here, the data requirements for you to be able to predict here, the data requirements, number one, you need what we call the technical coefficients matrix. We need what we call the technical coefficients matrix. Coefficients matrix, that is number one. And then number two, ladies and gentlemen, you need what we call the final demand. The final demand. The final demand. So you need the technical coefficients matrix. And then number two, you need what we call the final demand. So even before I define, I would want to define these things very well for you. But before I define, I would want you to know from today that the technical coefficients matrix will always be called matrix A, and the final demand matrix will be called matrix D. Matrix D. So we want us to look at a situation where A is given to us. If A, for example, here is given to us as 0.3, we have here 0.4, we have 0.25, and then we have 0.55, like that. And then a situation where they have given us the final demand here as 50, 60. And then we are required, ladies and gentlemen, to do something very easy. We are required, ladies and gentlemen, we are required here to determine the total output. In this case, determine the total output. Before I get to tell you even how we construct the technical coefficients matrix, and what final demand stands for, let's start by putting everything in perspective by, ladies and gentlemen, first of all, looking at how we do the modeling. Once we understand the modeling, then in this case here, the background to the model will be a straightforward thing, So this is my little example for you. I don't know whether you've been able to write, have we been able to put this down? Have we been able to put this example down? Have we been able to put this example down? It's an example, it's an example. Yes, thank you very much. So mention their solution. Mention their solution. Ladies and gentlemen, whenever you see yourself being given the technical coefficients matrix A, they have given you D, and then they want you to calculate the total output, which is our known, which is our X. This is what we shall be doing. To get our X, ladies and gentlemen, we shall be taking I minus A inverse multiplied by D to get X. X, which is what here somebody would have written, X is total output. X is the total output. So this is a formula that as we work hard, ladies and gentlemen, to understand this input-output model thing, this is something that you need to know from the word go, that X stands for the total output. It goes without saying that A, where you would have written this like yesterday, that A stands for technical coefficients. And then we have D, which stands for what here, somebody? Final demand. Ladies and gentlemen, listen. This model that you are seeing here has a special name in input-output. It is what we call the Leontief's inverse matrix. It is what we call the Leontief's inverse what here? Matrix. Leontief's inverse matrix. It is what we call the Leontief's inverse matrix. Leontief's inverse what here? Matrix. The Leontief's inverse. No. It is the Leontief's inverse model. Leontief's inverse model. It is this I minus A that we call the Leontief's matrix. And then we have I minus A inverse, which will be the Leontief's inverse matrix. Leontief's inverse matrix, ladies and gentlemen, the moment you write up to there, Please give me a signal. Tell me that you have written up to there for me to continue. For me to continue, tell me that you have written up to there. You simply say Y for yes. You simply say Y for yes. You simply tell me Y for yes. Great, great, great. So, ladies and gentlemen, I would want you to listen and listen to me very well. The first thing that you would want us to do in this question, if you are following this model, will be for you to get this Leontief's matrix. Because it is the Leontief's matrix that would want to inverse. It is the Leontief's matrix that would want to inverse. So if that is the case, ladies and gentlemen, this is what I would want us to do. This is what I would want us to do. I would want us to come as per body mass and ascertain what we call I minus A. So our I minus A will be, remember, if you watched your matrices very well, this is not one. This is not one. This is called an identity matrix. It's called an identity matrix. And remember, identity matrix, if you can recall, if it's a 2 by 2 identity, we talk of 1, 0, 0, 1. You cram it that way. So 1, 1, every other thing becomes what here? 0, 0, 0, 0. This is identity 2 by 2. Identity 2 by 2. Is there anybody who can write for me before I proceed with this? Is there anybody who can write for me identity, which is a 3 by 3? Identity, which is a 3 by 3. Is there anybody who can write for us identity, which is a 3 by 3? Identity, which is a 3 by 3. Great. Which is a 3 by 3. I can see what Sharon Gaetano has already written for me there. Ashajua kwamba the top row itakuwa 1000. Itakuwa, look at what James has written for us there. Top row itakuwa 100 because as we're 3 columns. And then remember, once 1 has appeared, we can never have any other number there other than zeros. Nikija kwa ya pili, sababu 1 imesha appear hapa lazima nianze 0. So niseme 0, 1, 0 like that. Right? Nikuja ya tatu, hapa already 1 iko hapa, so lazima itakuwa 0. Already 1 itakuwa 0, itakuwa 1 like that. That is it. It's called what here? An identity which is 3 by 3. An identity which is 3 by 3. Like in this particular question that we have, should we choose an identity that is 2 by 2 or identity which is 3 by 3? Which one should we work with? Which one should we work with? Identity which is 2 by 2 or identity which is 3 by 3? Which one should we work with, ladies and gentlemen? Which one should we work with, ladies and gentlemen? 2 by 2, yes. It's 2 by 2 because the matrix that we have here for purposes of compatibility, the matrix that we have here has got 2 rows with the 2 columns. So I should work with 2 by 2. Thank you very much. 2 by 2. So what I'll do, ladies and gentlemen, I'll come and see I minus A, and I can see what really my I is. I can see really what my I is. My I is 1, 0, 0, 1, like that. Minus A which is 0.3, 0.25, 0.4, 0.55. So from there, ladies and gentlemen, please go ahead and do the subtractions for me. Remember, subtraction, you'll always take corresponding elements. So like you say 1 minus 0.3, nakuja ngapi? Somebody 1 minus 0.3? Corresponding elements, 1 minus 0.3, who is able to give us the figure 1 minus 0.3. 1 minus 0.3 gives me 0.7. The first one is 0.7. And then now we have 0 minus 0.25. 0 minus 0.25, that gives us minus 0.25. So this gives us minus 0.4. This gives us 0 point, if you're following. We are subtracting corresponding elements. We are subtracting corresponding elements. So 1 minus 0.55 gives us 0. What here? Somebody gives us 0.45 like that. Now, ladies and gentlemen, if you are a keen student, having gotten this that is in brackets here according to body mass, having gotten this that is in brackets according to body mass, what do you think will be the next thing to be done, ladies and gentlemen, as per the formula? What do you think will be the next thing that we shall do as per the formula? As per the formula, what do you think will be the next thing that we shall do? As per the formula, what do you think will be the next thing to be done? Find the inverse. Thank you very much. Because this raised to minus 1 means inversion. This means inverse. So remember, we are not getting inverse of A. We are getting inverse of I minus A. Thank you very much, James. We are getting inverse of I minus A. The one that you've just subtracted here. The result of our subtraction here. So if that is the case, then ladies and gentlemen, if that is the case, ladies and gentlemen, then I would want you to do me a favor. I would want you in the inversion spirit, I would want you to give me the determinant of I minus A. Please come here and give us the determinant of I minus A. Give me the determinant of I minus A. So give me the determinant of I minus A. So determinant I minus A. Remember, it is PPD minus PSD. It is product of primary diagonal minus product of secondary diagonal. So the primary diagonal in this particular case, if you remember your concepts very well, the primary diagonal is the one that normally starts from the first element. The one that starts from the first element of the matrix, like this. This will be my primary diagonal. Even if you are left-handed, even if you are whatever, ladies and gentlemen, remember, when you are told by anybody to start writing up this equation, this matrix, you have to start from this element, right? You have to start from this, unless you are writing in Arabic. Arabic is where you write like this. Nevertheless, we are saying something very important, that the first element of this matrix is this one. So when you pull that diagonal like that, then that becomes the primary. So you're saying that the product of primary diagonal will be 0.7 times 0.45. Remember, product means what here that you're multiplying, right? Product means that you're multiplying. And then we have product of the secondary. Of course, the other one, which is lagging, will be my what here? Will be my secondary. So then this will be minus 0.4 times minus 0.25. So could you kindly give me the product of the primary diagonal up there? Kindly give me the product of the primary diagonal. Somebody is telling me that this one is supposed to be 0.215. Product of primary diagonal, somebody is telling 0.315. 0.315. Thank you very much. How about the product of the secondary diagonal? How about the product of the secondary diagonal? Product of secondary diagonal, according to Fatma, is 0.1. So please, you're supposed to subtract the 2. When you subtract the 2, you are getting 0.215 like that. 0.215 like that. And therefore, the inverse I minus A, which is written like this, will be equal to who? Which is written like that, will be equal to who? Will be equal to, so user anasema inafaa ikuwe 0.415. Uongo user, angalia. So najua, hiyo kimultiply na inakuwa positive. Kwa hivyo inafaa kuwa answer ya 0.1 positive. So when you take 0.315 as per the formula, subtract 0.1 out of it, it can't be 0.415. It will be 0.215. I really appreciate if you can confirm that you have been able to see what I'm talking about. You've been able to see your mistake. Or if you can go ahead and tell us, no, you guys are wrong. Right? Right? Is it supposed to be 0.215 or 0.415? Pata potea. 0.215. 0.215. Thank you very much. Thank you very much. Aha. Kwa hivyo inamaanisha wewe inverse itakuwa 1 over the determinant. 1 over the determinant into while inversing, what is it that we normally do? What is it that we normally do for primary diagonal elements? Primary diagonal elements, what do we normally do with them? Primary diagonal elements, what do we normally do with them? We swap them. Thanks, Gertrude. Gertrude has watched that video. Primary elements, we always swap them. Swap their respective positions. So 0.45 goes up there, 0.7 goes up there. How about secondary elements? How about secondary elements? Yeah, secondary elements, we change their signs. That is a better thing. Change their signs, yes. So like now here, you can see, ladies and gentlemen, this was negative. We retain their positions, but we change their signs. So we have here 0.25. Here we have 0.4 like that. Thanks. So now we've been able to get, ladies and gentlemen, we've been able to get 𝗘𝗏𝗓𝗔 inverse matrix. 𝗘𝗏𝗓 basically is not a Greek whatever. It is the name of the person who discovered the model. This is the name of the person who discovered the model. The name of the person who discovered the model. Ladies and gentlemen, having really gotten that, then everything for us becomes straightforward. Everything for us becomes straightforward. What you're supposed to come and do here is to come and remind them the model. Our model is x equals I minus A inverse multiplied by D. So then our model here, if I'm able to feed my parameters, my metrics here into my model, then the I minus A inverse is 1 over 0.215 into 0.45, 0.25, 0.4, 0.7 multiplied by D. Our D, if you remember very well, our D, which is final demand, was 50, 60, like that. Our D was 50, 60. Our D was 50, 60. Ladies and gentlemen, having really gotten this correctly, nicely, what you're supposed to come and do, remember, what you're supposed to come and do, you know, this that we have outside here will be called a scalar. The one that you have outside here will be called a scalar. So basically what you're supposed to do is to come and multiply the matrices first. We give matrix multiplication a priority. The scalar will be left outside. The scalar will be left outside. So we have here 1 over 0.215 into multiply our matrices. So is there anybody who can remind us the major concept of matrix multiplication? When somebody says multiply 2 matrices, what comes to your mind? Multiply 2 matrices, what comes to your mind? What comes to your mind? When somebody tells you to multiply 2 matrices, Roman Catholic, thank you very much. Roman times Catholic, row times column, thank you very much. So this is the row here, and that is the column. So could you kindly go ahead and do the multiplication for us? You say 0.45 times 50 plus 0.25 times 60. Remember, it is first ones multiplied plus second ones multiplied. First ones multiplied plus second ones multiplied. So naambiwa kwamba itakuwa 37.5. So remember, whatever I've done with this row, I have to do it with this other row. So this row, again, my buddies will multiply this first column there. This row, how do I do it? So long as I don't become like a person who has got 2 feet, which happens to be what here? Both left. Those kind of people who can't dance. You know, there are people who can't dance at all. They can't shake at all. They're so rigid. They're ever there. So ukimwambia multiply 0.4, 0.7 na hii, atakwambia ati ni 0.4 times 50 plus 0.4 times 60. Anakatalia 0.4. Hapa anakatalia. This thing needs, ladies and gentlemen, to move along as you go to the respective positions. So you talk of 0.4 times 50 plus 0.7 times 60, you give me a figure. What figure do we have? 62. I'm being given a figure of 62. Thank you very much. So after that, ladies and gentlemen, I know that the next thing will be for me to do what? To distribute the scalar here. The next thing will be for me to distribute the scalar. The scalar is very easy. You simply come and take like 1 over 0.215 times 37.5. 1 over 0.215 times 62. You get the 2 values. You get the 2 values into decimal places. Could you kindly help us? Into decimal places. What do we have here? Into decimal places. Into decimal places. What do we have here? So according to 𝗕𝒂𝒂𝒏, the first one should be 174.4, and then the second one, 42, 2 decimal places. 2 decimal places, 174.42, and then the second one, 288.37. 288.37. So it means that for these particular sectors, there are 2 sectors. For them to be able to satisfy total demand, they must endeavor to produce these outputs. So these are our predicted outputs. These are our predicted outputs. There are our X values, and because there are 2 X values, This could be like my x1, and this could be like my x2, like that. Now, ladies and gentlemen, listen. Your examiner will never give you A directly like that. No. What your examiner will do, your examiner will come and give you this kind of a question. It'll come and tell you, we have here from, right? We have here two. And then we have got two sectors. We have agriculture, we have mining, right? So we have the same metrics here, agriculture, mining. Then we have the final demand. So it'll come and give you here what we call the total output. So it'll tell you that agriculture in the year, agriculture produced 100 kilograms, could be 100 million kilograms. And for example, mining produced 200 kilograms of limestone. Limestone is quite useful. So now from agriculture, ladies and gentlemen, from agriculture, in the year, of course, there will be, in this case, there will be quite a lot of transfers between departments. That's very normal. Transfers between sectors. So for example, agriculture could have sold some bags of maize to the people who are in the mining industry. So in this case here, perhaps they could have taken like say 30 kilograms to mining sector. And then, ladies and gentlemen, we could be having some maize which flew out of the sectors, for purposes of final consumption to us consumers, here. Perhaps you could talk of how many kgs, 25 kgs went for final consumption, what we call final demand. So then agriculture itself in these cases, and gentlemen, retained how many kgs for further production. Nabakisha mahindi kama ile siku za kitambo rutuba ilikuwa mzuri, unapanda hiyo mahindi tena. So agriculture, because they must add up to 100, then agriculture must be what here? I'm being told 45. Now mining ikapeleka pia vitu kidogo katika wapi agriculture, for example, in form of water fertilizers. We need, ladies and gentlemen, we need limestone when making fertilizers, right? So agriculture ikapeleka, for example, 20 to mining to agriculture 20. Mining for final consumption, ladies and gentlemen, perhaps 80. So kumaanisha, ladies and gentlemen, mining libaki ngapi hapa? Somebody mining alone. Balancing figure. The balancing figure mining. The balancing figure mining. Thank you very much. Thank you very much. Now listen. Then we'll come and talk of what we call the total input. You see, up there we have output, and then here we have the total input. Can somebody give me the total input of agriculture? What is the total input of agriculture? Total input of agriculture. Total input of agriculture. Ningapi? Somebody total input of agriculture. 65. Thank you very much for trying. Amaya, thank you very much. However, that is a lie. The total input for agriculture is 100. The total input for mining is 200. Is there anybody who is able to see where I'm getting those figures from? Is there anybody who is able to see where I'm getting those figures from? Is there anybody who is able to see where I'm getting those figures from? Anybody who is able to see where I'm getting those figures from? Have you ever seen these figures anywhere else? Yes, total output, yes. Because the first condition that you guys are supposed to master as students of input output is a total input. Total input will always be equal to total output. Once you get this wrong, then you can never really get anything out of this. It's a system of no losses. You put in 100, you get exactly 100. Total input will always be equal to total what here? Output. Total input will always be equal to total output. Very important, yes, very important. Then the balancing figure here means that we must have gotten some raw materials here from other sources other than sector. And whatever raw materials you get from sources which are not sectoral, we normally call these primary inputs. The primary inputs. So primary inputs will be constituted by things like labor, right? Entrepreneurship, the factors of production, if you remember them. These can't be borne by any industry. They can't be given by any industry. The primary, the essential inputs. So they should be balancing figures. So could you kindly give me the primary input for agriculture? Give me the primary input for agriculture. Give me the primary input for agriculture. Inakuja ngapi? Somebody, James ananiambia inakuwa 35. How about the primary input for mining? How about the primary input for mining? Primary input for mining, 200 minus this. 70. So listen, what will happen? Your examiner will give you this kind of information. And out of this information, he'll ask you, you'll be required here to calculate the technical coefficients. You'll be required to calculate the technical coefficients. You'll be required to calculate the technical coefficients. So let's first of all calculate these technical coefficients. Let's calculate the technical coefficients. Have you written up to here, my friends? Have you written up to here, my friends? Yes. So, yes, thank you very much. So technical coefficients are basically the input ratios. So tell us there that these are the input ratios. These are the input ratios. We normally call them A. And for us to get A, I only need, because I've got two sectors, I only need to go to my columns. Remember, we must first of all start by planting and then we harvest. We start by planting and then we harvest. So the input is a benchmark. So here we normally go down. So like now here we'll talk of 45. So the input ratios of agriculture. The input ratios of agriculture, this will be 0.45, this will be 0.2. Remember, in input ratios, we only capture information about sectors. We can't have an input ratio of the primary inputs, no. So it is only between sectors alone. How about the input ratios of mining if you're following? If you're following, input ratio of mining itakuwa gani somebody? Input ratio ya mining itakuwa ngapi somebody? Just try. 0.3 and 0.1. Thanks for trying, but be keen, be more careful, be more careful. Remember to be more careful, be more careful. Input, what is the total input here for mining? Not 100, it's 200. You know, this one here was 100, so we took 45 over 100. 𝒘𝗏𝗏 is still saying 0.3 and 0.1. No. You know, it will be 30 over total input, which is 300. Should be 0.15. And then now we have 100 divided by 200. 100 divided by 200 is not 0.1. It becomes what here, somebody? It becomes 0.5 like that. It becomes 0.5 like that. So remember that in Markov, we normally move. How do you move in Markov, if you remember that way? For input-output ratios, these technical coefficients matrix A, they are input ratios. What is the total input? That becomes our benchmark, and then we divide downwards. It has to be a square matrix. We don't incorporate final demand. We don't incorporate primary inputs into matrix A. Into matrix A, we don't incorporate those things. You don't incorporate those things there. Any question up to there? Any question? Any question? Any question from your side? Any question from your side? Any questions from your side? Yes, Maurice. So, ladies and gentlemen, remember, you'll get a situation now in another requirement where the examiner tells you to determine the output if this final demand changes, and you're being told, yeah, if it changes to 30 and 90 for agriculture and mining water respectively. Then in that case here, what shall you do? That is very easy, very easy. So what I need to do, this table now is useless. Now I need to come and remember the Leontief's inverse model, which tells me that my X should be equal to I minus A inverse times D. So and then now you go through the entire process that I've just shown you in a few minutes ago. So is there anybody now who has a question before I tell you what next should we do? Good. So the most important thing is for you to appreciate a few terminologies, just two, before we call it a topic. Like, for example, somebody may want you to define what final demand is. Final demand, ladies and gentlemen, represents the portion of total output, that is not consumed, that is not consumed by the sectors, It is not consumed by the sectors. It is the portion of the total output that is not consumed by the sectors. It is the portion of total output that flows out of the sectors for purposes of consumption, inventory accumulation, or exportation. It is also known as, aka also known as exogenous demand. Demand from outside. So have we written up to here? Have we written up to there? Not yet, okay. Portion of total output that is not consumed by the sectors. It's portion of total output that flows out of the sectors for purposes of consumption. Inventory accumulation, like now what we normally take to Kenya, this KPCU, whatever, growers, whatever, yeah, for purpose of consumption, inventory accumulation, or what is even exported out of the country. The major thing is that you're not utilizing that for inside the sectors again. This is the opposite of what we call intermediate demand. Can I rub this? Yes, only one yes, not sufficient. Only one yes is not sufficient. Amaya, yes. Thank you. Great. So from there we have the intermediate demand. So intermediate demand, ladies and gentlemen, what do we have here? Intermediate demand. This basically is demand from within. What What is produced by the sectors and consumed by the same sectors? Produced by the sectors and consumed by the same sectors. Produced by the sectors and consumed by the same sectors for further production. 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 So if it's agriculture, they have done 100 bags of maize as their output. They may retain like 10 bags to utilize this as what? Yeah, seeds. So if they retain some output, which, ladies and gentlemen, they utilize for further productivity, then the output that has been retained will be known as what? Yeah, somebody will be known as intermediate. Will be known as intermediate demand. Intermediate demand. And then we have the last one. If you check your past papers, you'll be able to see these definitions. The primary inputs. The primary inputs, these are non-sector inputs. Non-sector inputs, non-sector raw materials. Those raw materials that can never be provided by any sector. That can never be provided by any sector. Very good example will be entrepreneurship. Entrepreneurship. We have labor. We have land. We have capital. There is no sector that produces these things. No sector that produces these things. So then we have to lump them together under what we call the primary inputs. The primary inputs. But now, ladies and gentlemen, if I'm the one who will be given a chance of setting, especially those days when I used to be young, and more aggressive, they really used to give me this work. But nowadays, of course, I'm quite old. Nobody wants to work with who? Only people. If I was to be given a chance, to set this exam of yours of August 30th, what I'll do, I'll come and give you a three sector thing. I'll come and give you like A of 0.3, 0.1, maybe 0.2, 0.15, maybe 0.25, maybe 0.4. We have maybe 1, 2, 0.13, 0.1, maybe 6, like that. And then I'll give you D of say 50, 60, 70. And then I'll ask you to get us the total output. I'll ask you to get us the total what here? Total output. Total output. I'll ask you to get for us the total output. You give us the total output. What do you think, ladies and gentlemen, is the technical thing there to be done? Okay, ladies and gentlemen, what do you think is the most technical thing to be done here? Here, of course, I would expect you to be good at the 3x3 matrix inversion. If you're good in this 3x3 matrix inversion, then you are good to go. You are good to go. You are good to go. 3x3, like that. And I want to believe that for those of you who watched those video, or rather that video of matrices, this is not going to be a tough thing for you. This is going to be a simple thing for you. So can we agree that each one of us in this case will try this question as part of your homework? As part of your homework, as part of